Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, I want to continue the same example. Now we are going to discuss step number 3C. We are going to calculate the R prime value. In my previous video, under step 3B, I have explained how we determine the end moment in table number 2. And table number 2 under step 3 is actually we distribute moment for sides waveframe. Okay, refer back to sides waveframe. Okay, this is actually diagram under diagram D, where we will analyze the frame which is subjected to R prime. The frame is moving towards a right direction. Okay, so the free body diagram for the frame, we put the unknown reaction at A, unknown reaction at D, and R is located at C in the right direction. So we focus on the all horizontal forces inside the diagram, which are R prime, H1 prime, as well as H2 prime. So we will relate all this under the shear equation. The shear equation. Okay, so we have to write the shear equation. The shear equation is this one. The shear equation is H based on the diagram just now. So it is H1, which is also equivalent to AX prime. So this is AX prime actually. This is DX prime. Okay, so we have AX prime as well as dx prime. So in this case, we use h1 prime and h2 prime. So we all these are the horizontal forces in the diagram. Okay, in this diagram, so we relate all these horizontal forces using shear equation. So we will get h prime 1 minus h prime 2 plus r prime, we get 0. So our task after this is to calculate h prime 1 and h prime 2 in order to get the r prime value. So r prime value is needed because we want to calculate the correction factor. Because why we have to calculate correction factor? Because under step number 3, FEM is based on assumption. So the negative 100 we assume for member AB is actually based on assumption, because we do not know the delta prime value. So that is why we will have the correction factor at the end of analysis. Okay, now I will show to you how we get R prime. Okay, so after we have assume and calculate the FEM for each member in the frame. So we use all the fixed end moment based on assumption in the table. So from the table we get M prime. So these are all the end moment for sides waveframe. The frame due to R prime. So we get six value for AB, we get negative 91.884. For BA, we get negative 83.655, and then we get uh, positive 83.655, and then we get 42 and negative 42, and last value M prime DC is negative 33.974. So this all six value and moment we get from table number 2. So we will use this moment value, the end moment value, to calculate H prime 1 and H2 prime, or AX prime and DX prime. Okay, so let's okay, jump to this diagram. This diagram actually shows the free body diagram for each element, for each member. So I have uh, actually draw the elements separately, the members separately. So for member AB, so this is actually the internal forces occur for member AB. Uh, at A, because we know that there are three internal forces. There are three internal forces in X direction, in Y direction, and in Z direction. In X, Y, and Z direction, vertical, horizontal, and in Z direction. Okay, so we have three type of internal forces. With three type of internal forces, and for the element, the system must be in equilibrium. System means the structure, and element also system one, system for element, join or join also a system. So every one of these we have to make sure that it is in equilibrium. The structure must be in equilibrium, the element must be in equilibrium, the joint must be in equilibrium. So by looking at this diagram, member AB, so we have to make sure that the total V total V is equal to 0, total H also equal to 0. So we will get V prime, 1, V prime 1, 1 is positive, 1 is in negative direction, to get equilibrium, to fulfill equilibrium condition. So same goes to H. So H, one is positive, one is negative. The value will be the same. So it occur in opposite direction to remain equilibrium. To remain equilibrium. So V prime 1, V prime 1. Okay, same in opposite direction to remain equilibrium. And of course for each n A and n B, we have n moment, and the value of this we get from the table. This negative 91.884, negative 81.884, and for BA is negative 83.655. This is negative 83.655. The moment sign is negative, is counterclockwise. Okay, so that is for AB. That is for AB. Okay, now look at CD. Look at member CD. Okay, for member CD at D, normally at D we have dx and dy. Now the dx and dy is written as V prime 2 and H prime 2. V for vertical reaction and H for horizontal reaction. Okay, and the element is a system, is one system. The system must be in equilibrium. So from the diagram we can see that this value should be the same with this. Okay, one negative, one positive, then only the equilibrium is fulfilled. And for the horizontal forces as well, H prime 2, 1 negative, 1 positive, to remain equilibrium. Total Fx 0, total Fy 0, or total V 0, total H 0. And beside that, there are n moment at NC, and n moment at ND. N moment at NC is MCD, and n moment at ND is NDC. So this value we get from table number 2. So MCD from the table is negative 42.965. This one negative. So the negative in the diagram representing by counterclockwise moment, and negative 33.974 is M prime DC, M prime DC. So at D, so actually we will have 33.974. It is negative, representing by a counterclockwise moment. Counterclockwise moment. So this is diagram CD. Okay, and then we just need to look at to member BC. Member BC. So for member BC, so we get the equilibrium condition, okay, at joint B. At joint B, the joint B also a system, so the system must be in equilibrium. That is why we have to check this as well for the for the total horizontal forces, and horizontal and as well as vertical. So total V is equal to 0, total H is equal to 0. So that is why we find that here this one is negative, this one is positive. So the equilibrium is fulfilled. And another one is in horizontal direction for H. So for H, so this is H1 in left direction, and H1 also in right direction. So the system is in equilibrium horizontally and vertically. Okay, so beside all this, of course, at joint B, there is a moment MBC, and we get this from table. It is positive, it is clockwise moment. So in the table, so this is the clockwise moment, because sign convention that we use clockwise positive. So the 83.8.655 positive, representing moment at B, which is acting in clockwise direction. Okay, and the next value is at C. At C, okay. First thing to check is the joint condition, the joint equilibrium. For joint equilibrium, we just need to check this. Okay, so total V must be equal to 0, total H also equal to 0. So that is why, so this one is V2, this is V2 as well, V prime 2 as well. One negative, one positive, opposite direction. And another one is H. So we find that this is H prime 2 positive side, and H prime 2 negative side. So the system is in equilibrium horizontally. Okay, and at C, there is moment MCB. The value is 42.965. 42.965. The direction is clockwise direction. So because from the table, the value is positive. Positive mean clockwise. Positive mean clockwise. So from this, so this is actually the free body diagram for each element. So we have put all the internal forces. Okay. And from this, we will calculate. Since we would in order to calculate R, we have to have H1 value and H2 value in order to calculate R. In order to calculate R, we have to find the value of H prime 1, and we also need to find H prime 2. Okay, so H prime 1, uh, H prime 2 we can get directly because the member is vertical. H prime 2, this one, we can get directly by taking moment at C, we can get H2 prime. However, for H1 prime, we cannot get direct value because there are two unknown H and V, H1 prime and V1 prime. Okay, so in order to solve for H1 prime, so we have to calculate the V prime first. Okay, so how to get this v prime 1? So we will get from beam, for beam BC, because the value is same. Okay, the value is same, so this is also v1, this is also v1. So we will start with analyzing member BC. Okay, so we have to consider member BC first, and by taking moment at C, so we get V1 prime. Okay, V1, V prime 1. So we get the value is equivalent to negative 21.103 kilonewton. This is beam analysis. Okay, we analyze this just like we determine or we calculate reaction at the support using it is just like simply supported beam, where we calculate reaction using uh, equilibrium equation. So we will get V1 prime. Okay, so once we get V1 prime, then we will consider a member. First is member BC. Next, we will consider member AB. So why we want to consider member AB? Because we have determined V1. So we will substitute V1 into the equation that we get for member AB, and then we will get H1. So what we want is actually H1, because from H1 we will get from H1 prime, and from H2 prime we will get R prime. Okay, so we will consider member AB and taking moment at B. So we just need to analyze this column AB, this column AB. So V1, we have get the value from previous analysis, from analysis of member BC. So due to this, we can calculate H1 by taking moment at B. So we will apply equilibrium equation here, and then we can calculate H1 prime. So H1 prime, from static equilibrium, we get equal to 59.712. 51.712. Of course, we have to check the trigonometry for the this is A B. See, this is 5 meter, this is 3 meter. So we have to find the y value, which is equivalent to 4 first. Then only we can calculate this value. Okay, and so since H1 has been determined, so next step is to calculate H2 value. H2 is actually, so H1 is actually AX prime, H2 is actually DX prime, DX prime. So to calculate DX prime or H2 prime, we just need to consider member CD, and by taking moment at, so we just need to consider this, and by taking moment at C, by taking moment at C, we can get the H2 value, and from static equilibrium, we get H2 is equivalent to 8.549 kilonewton. Okay, then from the shear equation, so we substitute H1 prime and H2 prime, or AX prime DX prime, we substitute into the shear equation, then we will get R prime, and R prime is equal to 68.261 kilonewton. 68.261 kilonewton. So this is actually what we should do under step 3, under step 3C, where we have to calculate the R prime value. Then actually for R prime value under step 3C, have similar analysis with step 2C. So step 2C is to calculate R value. Step 3C is to calculate R prime value, because we need R value and R prime value to calculate the correction factor. The correction factor that will be used in order to find or to calculate the final end moment. And correction factor is equal to R divided by R prime. Okay, so for step number 4, for the next step to calculate final end moment, we will continue in the next session. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.